Hi, in this session we will talk about another important component of OpenRAN, which is Open Centralized Unit. Central unit in the OpenRAN has the multiple responsibilities of Layer 2 and Layer 3. From the Layer 2 perspective, Open Central Unit takes care of PDCP Protocol, which is Packet Data Convergence Protocol, and SDAP Protocol, which is Service Data Adaptation Protocol. And from the Layer 3 perspective, Open Centralized Unit consists of radio protocol architectures and takes care of RRC, radio resource controls. RRC is one of the most important protocol needed to establish and maintain a consistent connection between the end user device and the network. Okay, let's start from the L2 functionalities of Open Centralized Unit. So you can see the 4 protocols of the L2 layers over the screen. Out of these, we talked about the RLC and MAC protocols, which are actually being catered by the Open Distribution Unit. SDAP and PDCP are the protocols which are being handled by the Open Centralized Unit here. So you can see that how the data is being transferred from MAC to RLC to PDCP to SDAP. Each protocol layer adds some additional information over to the received information, which also called the header bits, and then pass it to the next protocol layer. So here data is coming in terms of IP packets from the upper layer. You can see layer 3 here. This data traveling in the layer 2 as a SDU, Service Data Unit. These all information are encapsulated in a kind of radio barrier. So you can see that the IP packets are encapsulated in multiple SDUs and they are combined in the radio barrier. Means one radio barrier can combine more than one SDUs or IP packets. And later these are converting into the transport block at the MAC layer. This is just a high level that how the data flows from higher layer to the lower layers. Let's talk about some of the basics of the PDCP protocol. PDCP is Packet Data Convergence Protocol. PDCP protocol provides services to both the control plane as well as the user plane to the upper layers or higher layers, where RRC is basically used for the control plane information and SDAP is used for the user plane data. PDCP protocol is responsible for header compression or SDU, Service Data Units. PDCP layer also checks for the integrity protections and uses ciphering for security. In the last, PDCP headers gets added in the SDU and remove any kind of duplications. Now the data will move to the lower layers and gets transmitted to the another point, where PDCP protocol receives that information. Here now the PDCP layer will do the deciphering and PDCP layer will discard any kind of duplications and reorder the SDUs in the right form. Then PDCP layer decompress the header which was added during the header compression stage earlier, and then it will send the original data back to the higher layers. If you notice, then at receiving end it reverses the actions which was taken at the transmitting end. PDCP works for both control plane and user plane, depends on the type of radio barriers coming from the higher layers. PDCP also plays the important role in DC. DC is dual connectivity mode and it can be associated with 1 or 2 or more RLC entities, depends on the type of multi-connectivity barrier. So in dual connectivity, PDCP provides the different radio barriers for master cell group and secondary cell groups. And these radio barriers in the multi-connectivity mode handles by the PDCP layer. SDAP is the another protocol which is handled by the Open Centralized Unit. SDAP is Service Data Adaptation Protocol. This is responsible for the QoS flow handling across the 5G air interface. We specifically mentioned 5G here because it was introduced with the 5G evolution. It was not available with 4G or LTE. It receives the packet from the higher layer and add up the QoS flow ID with each and every packet before forwarding the SDU to the lower layers. In the screen you can see how the packets are being transferred between the UE device and the G node B through the radio barriers. Each packet here is being assigned with the QFI. I have also added the UPF part here, which is actually a core network function, but this is how end-to-end QoS looks like in 5G. SDAP structure is configured by the RRC. The SDAP layers maps QoS flow to the DRBs. The SDAP sublayers maps the QoS flow to the DRBs. One or more QoS flows may be mapped onto one DRB, but one QoS flow is mapped onto only one DRB at a time in uplink. The SDAP entities are in SDAP sublayer. Several entities may be defined for a UE. There is one SDAP entity configured for each individual PDU session. In the next session, we will be talking about the layer 3 functionalities which are being handled by the OpenCU. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video and don't forget to share. Thank you for watching.